switch it up for you on this end. And then we'll be back on vocally. Well, I will. I'll be back on with him. I don't know if he's going to just play music for like 10 minutes or so to give us a little voice break, but okay, cool. Sounds good. But once again, I thank everybody for joining us. There is a chance we might try to go for another one tomorrow night since Monday is Labor Day. And don't forget the Artemis launch. If they happen to schedule it for Monday, we will be carrying that as well. If they attempt to get it off and everything's on. So, yeah. So I'm hoping everybody has a great night. You'll hear us here. Once again, the only thing that's going to be switching is your view. You're going to get, from Mark's channel, but you're still going to hear us, so you guys can kick back and watch here or go to Mark's channel, whatever you want to do. You'll hear the same thing either channel. And, yeah, and then we'll go from there. Sound good? All right. See, and I'm just going to give the P and K boom there, and as we dump out of Paul, let's see what happens. There we go. We will dump out of him. Yeah, and don't forget to send me that link. Yeah. I just need the video URL. The video I will try it. Let me go here. Oh, hi, Mark. Properties. There we go. Let me get the link from you. Super. Where you at? Oh, there's chat. Gotcha. Here we go. Copy link. Alright. We will dump out of Paul's feed. Man, we almost look like we know what we're doing. Alright, let me do that.
Hello and welcome to Skyter Livestream.
Keith, wait, I hear myself.
You probably do. Keith and I are going to take a little break and then we'll come back. For now, I've got the moon up here for now, but I'll come back. And we've already got a bunch of people in here, Keith. We got
I hear it echoes like crazy.
I know, that's because you got a couple of sources going on, but that'll change when you get out of yours.
Here, let me do this.
All right. And PG, hello Petita. Robin Curtis is here. Hello, Robin. Alice Pooper, Taryn Marie. And that's the early crowd. You guys are early. Bonnie was first. Fantastic. I'm going to disappear for just a few minutes to get my drink and refresh my voice. But I'm also going to change the zoom level. Let's bring it up a little higher. Go to about 75% on our sensor.
There we go.
Up here. Okay, there we go. And if we were to increase our exposure, we might actually see the other side of the moon. Yeah, we do. And if we move this over, here you can see the unlit side of the moon over here. That's pretty cool. That's the unlit side. But it's going to be lit before long. And we'll change the exposure down now. It's a little too low. There we go. That's too much. And that's just almost right. Not quite. Alright, so you need to take a break.
Right. I think I got it all figured out. You are live on P&K. And guys, we'll be back in a little bit.
Oh, I see myself over there. Fantastic. Alright. Alright, guys. Well, we will be back in just a short period of time. So, enjoy yourself. Yeah, more moon for now. That's all. More moon. That's like more cowbell.
More cowbell.
Yeah. Ding, ding. All right, folks. Be right back.
Yep.
All right. And away we
I do have you muted on this side. I have both of us muted on this side, so. I guess you can do the same thing on that side. That is a yes. There we go.
You back already?
What's that?
You back already?
No. I was getting the stuff set up. I'm actually stepping out for a second here.
Okay.
Yeah. I just wanted to make sure all the mics and everything were working and your channel looked good over on our side, so
Good.
It looks good. All right, I'll be back.
Alrighty.
I gotta tell Paul that we're clear too.
Okay. Well, for those of you that are just joining us, good to see you guys. Welcome from the other stream. I have two monitors, and on that monitor over there, I had that other stream, and then my stream is here with you guys. Good to see you guys tonight, and I know that we have an awful lot of possibilities tonight, and we are fighting some clouds that are coming in from the south, and that's not a pleasant thought. I don't want any more clouds, but let's see what we got. Yeah, they're moving closer. But you know what we can do? I have an all-sky cam, and I'm going to see if I can get the all-sky cam up. I've been suffering glitches with it lately, but I'm working on it. Let's find out if it'll give us at least an image. We'll do one acquisition, 12 seconds. If it keeps counting past 12 seconds here, it means that the camera was lost. There's a lot going on here, and that's one connection I haven't worked on. Yeah, see, it's going. Yeah, see, it has a problem. Okay, if I quit all this, it'll work fine. So that's just weirdness. And hello to Kathy Pernisek. How are you? Good to see you. Oh yeah, I am. I'm very happy to see you guys. And we're gonna actually do something as quick as possible here, because I know that this these clouds may move in shortly, and I don't know. It looks like that they're going right across, but they look like they're creeping up little by little. But we'll try very hard to make this not happen. Yes, Keith always has a great shot of the moon. That's their specialty. Okay, our specialty is, of course, the deep sky. And I've got our system set up here right now. You can see that our telescope is sitting here. You see STLS right here. That's the telescope. And that's where we're looking. And let's just try something while we're here. It's not quite dark out there. But we're going to go to this nebula right here as a test. And this nebula test might be a good one to try. All right. So first things we're going to do is we're going to increase our gain. We'll go to 250. Okay. And our exposure is going to be 1 second. Right. And we'll just do that here. I can set anything I want, but this is just for now. Okay. Yes, that's bright. All right. But we're going to come off of that right away. In fact, I will do that now. Let's just head to the east. Here we go. Move the moon out. Welcome back, Keith.
I'm trying to figure out why I can't hear you on my phone audio.
Huh.
I think I heard you on computer audio.
Okay.
And no, I'm not back yet. I came up real quick just because I was trying to figure out
Okay.
why I can't hear you on the audio.
Yep. I want to welcome M. Turner. How you doing? And Marianne is with us. Hello, Marianne. Please don't tase me, Marianne.
Marianne, do me a favor and jump over to P&K and see if you can hear him.
Oh, there you go. That's a great idea. Okay.
You might want to talk.
We're moving over to the Trifid Nebula right now. We're going to go into night vision mode. Right here. There we go. And we're 75% zoomed in. And we'll just leave it there. So that's the star we're going to center up in our view. Let's see how far off it is. That's the center of the view right there. Not bad. Okay, it's going to center up Nash. That's what it's doing there. That's pretty good. So our telescope is quite well aligned tonight. Oh, and there is our Trifid Nebula. It's beautiful looking. Yeah, we can move this over. We're not moving the telescope, we're just moving the view.
It's so weird. I can hear you on the computer.
Okay.
Like I'm watching on YouTube on the computer.
Yeah.
On the P&K channel, but I can't hear you on the phone audio. On
Your
the
headphone
P&K
audio.
channel. No, the phone, my actual phone.
Why are you on the phone?
Because that's how I check it when I'm downstairs.
Oh, I see what you mean.
So I'm just checking the feed to see if I got the audio from you. But I hear I come up here and I test the audio here on the P&K channel with your stream, and it's on. I can hear you.
Okay.
It's just weird. Maybe it's just my phone being goofy. Either way, continue. And then
maybe
I'll be back.
Maybe you can't hear it.
No?
So this is the Trifid Nebula right here. This is a beautiful nebula, which is, again, we're in night vision mode, but wait until you see it, okay? I picked this music especially because it seems to remind me of all the majesty of the universe. And so, you call me corny if you wish, but I am. I'm quite corny. Okay, let's do it's not quite dark, but let's try a 15 seconds on this nebula, and we'll have a little bit of a glow from the moon that peeks through. So we're going to get rid of our night vision mode and go into a stack. All right, and we'll clear this stack because I did a moon stack earlier. And now our first image will be right there in the middle of the screen, and it should be a pretty nebula. There it is. And that little bit of glow you see is due to the moon. But down here, see these three curves, red, green, and blue, with this white curve being the additive sum of all of them, that is the average. This is the dark level. Right now it's way off to the left, meaning it's too bright. So if I move this over, okay, if I bring it in here, I cut off some of the red down here, so it looks a little more blue. But if we color correct, all those curves line up underneath each other and we'll get proper colors. All right, so here we go. Watch. There we go. And our guiding wasn't quite ready, so I have to come into my guider here and check out, set the right ascension rating from 66 to 15. And the right ascension is the east to west motion, and the declination that you see right over my head there, declination or dec rate, that is going to be set to 17, Keithy boy. All right, and now I come up and we do this. We enter this, and now what you'll see is those numbers show that we're guiding. So what I'm going to do is I'm going to clear this and let it come in again. I may have to do this another time because I'm going to do this right as we're getting this. All right. Oh, look at that. Really pretty. Now what you're going to see in this next exposure, you're going to see much of this color modeling go away. Watch. Here we go. Boom. Look at that. Darker, more beautiful nebula visible. And we can actually darken it up a little bit more. Add some contrast. Show you what's really going on there. Look at that. That is the Trifid Nebula. Wow. That's really pretty. That's 75% of our frame. In the actual sky, it's that big. And remember, we have 4 full moons across and 3 full moons tall. So it's just about just under the size of a full moon. Okay. And this is in the south where we have some clouds, so I'm risking it. Keith, you still with us? I see we're still connected, so he must be troubleshooting a problem. Yeah, he's there. Look at that. This additional emission nebula, this is stuff that's, you know, part of this whole area. And if we get rid of this and let it just hang down below, we can increase the size and let you get it a little bigger here. And then I can actually probably take out that name. We don't need a name in there right now. So I can center this up for you. Here we go. Wow. Now we have stacked 8 frames. So what happens is we take an image, take a second image, align it so they're perfectly aligned, and we just keep doing that over and over and make a stack. So all the faint material, the faint black areas, that are like dark clouds of gas and dust, they actually get more and more pronounced the more we stack. So the more we stack, the better the imagery. And that's pretty cool. So if we come in here like this, all right, come right in. Okay, now we're at 133%. And I haven't even focused yet. I focused earlier, but I haven't focused. Yet. Taryn says he's eating cornbread. I bet he is. Look at that! Wow. So this nebula is created by these hot stars in the middle ionizing the hydrogen gas and making it glow red. Okay, but these blue area here, that is either one of these stars out here or a star we can't see. Maybe that star, but I don't know. It's kind of too red. Sending out just light, and when a star sends out its light, it has red, orange, yellow, green, blue, indigo, and violet light in it. Well, that blue light, those are short wavelengths, higher energy, and the dust loves to scatter that blue light. In fact, blue light it's a foregone conclusion that happens. The reason this is blue is the same reason our sky is blue, because the molecules in our atmosphere also scatter blue light from the sun. So we see blue light everywhere we look in the sky because it goes randomly in all directions. Same thing in a nebula. That's what we got here. So that's pretty cool. It's a good night. There's not any wind so far at all. And I think we're going to go from here straight up into Sagittarius. I want to check, well, not quite Sagittarius yet. I want to show you this guy, but we'll get there in a minute. So this is 15 seconds exposure stacked. Now I'm going to improve the quality of these right now in an instant just by adding something called an unsharp mask. So here we go. Watch the quality change. Okay. I know it didn't look it, but this is all sharper now. Really beautiful. Hey, he's back.
Okay, here's what I'm going to do. For the people watching on the PNK channel, you might hear something double real quick. What I'm going to do is I was wondering why it wasn't adding up, because I'm taking the audio from me and Mark's call, and it's not lining up with what he's saying. So I'm going to switch to the audio from his video. That way he lines up with what he's saying
Very
for
good.
you. So you might hear double audio here for a second, but besides that, then we'll be good.
Okay. Or I could just talk like this. And then everything would be cool. I'm kidding. I'm doing that on purpose. Oh, beautiful. Oh, yeah. Thank you for joining me, guys. I'm so glad you guys could be here. Marcin Johansson. Hey, you're funny. Hey, Cosmic Ray. What's going on? P&K, he's fixing the audio over there, Cosmic, to align it. We're simulcasting at the same time on Keith's stream as well, because I was on the stream with the moon thing earlier. Hey, Bullwinkle, what's going on? Okay, somebody asked me a question up here. Marcin asked. Yes, Marcin asked, is that called Rayleigh scattering? Yeah, Rayleigh scattering is exactly the reason why we see this blue. You're exactly right, Marcin.
All right, I'm not going to be able to do that because you and the what you call it are on the same channel, so you just hear both talking at the same time. So yeah, your words are going to be off from what your mouth is doing, but they'll get the gist.
Okay,
we're good.
Are you sure you didn't see me like doing this and talking like this?
No, it was both audios were coming across the same time, like our call and the YouTube audio were coming across the same channel. So, you know,
yeah,
tis what it is.
Yeah.
Hello, everybody.
Hello and welcome.
Find yours so I can pull your chat out so I can keep an eye on it.
All right. Yeah, because I don't know. Is anybody in your chat?
Yeah, you still got 15 to 20 people bouncing up and down.
Oh, I see that. Yeah, got a few. Yeah. All right, cool. Okay.
Yeah.
So 29 stacked. We're going to go to 30, and we're going to stop this at 30 images stacked. And I've got it labeled up here. And, of course, as you know, it's the Trifid Nebula. Now what I'm going to do is I'm going to save it, and you'll see a blue bar up there. Well, it is there because it's such a short exposure. There we go. It's actually an astronomical FITS file, and then I'm going to save it exactly as seen, and that's the ping file. So that's saved up to the online database. So the observatory in the desert right now is shipping these images up to the cloud, and they'll be available on a worldwide server in seconds, okay? And you'll be able to go there, check it out, and download all of these. All right, so if you want to know where to go, it's right there, skytourlive.com, also skytourlive.org. And you go to skytourlive.com and you scroll down one level, just to the next section, and it says, you know, go take me to these pictures, and you click the one button and it will take you to the directory where all the pictures are. And if you want to go to a particular date folder and just drill down until you see the processed folder, and that's where the images that you see right here on the screen are located. Okay, we're working on other things too. We're trying to figure out a way to create a database so you can access all versions of this particular thing we've taken through the years. That's another thing we're doing. So that would be the cream of the crop, the icing on the cake. And I actually wrote database software in my past, so I can do that, and I'm going to try and figure out a way to do that. Anyway, so this is done for now. So what I can do is I can actually clear it because we've saved it already, and we'll get rid of our stack, and we will go back to doing our 1 second shot, and I'll go into night vision mode again so we can see a little clearer what's going on. There we go. Yep, that's really cool. All right. And now we'll go out to our auto mode, show the whole frame in the view. All right. And now we'll go to our planetarium view. Pull that up. And this shows us where we are. There's our Dumbbell Nebula. All right. And we're going to go check out the Dumbbell Nebula.
Right. All right. I think we're good.
Alrighty.
Should be good to go.
Off we go.
Off we go.
Yeah. So you ready?
Yep. All good.
All right.
The only problem we have is the audio's off from your mouth movements, but...
By how much?
Well, you're on low latency, right?
Yes.
Mm-hmm. It's maybe like 4 or 5 seconds.
Okay.
Total.
I said this before. This song, you can't hear the song, I guess, but the song sounds like the theme from Stargate. You know, it just reminds me of Stargate for some reason. Yeah. So that's cool. All right, so we are centering Albireo. This is a beautiful double star that looks like, well, it's obviously 2 stars. There it is, an orange component and a blue component. They're the most beautiful double stars. There's the colors. I want to show you that. And then we'll see the Dumbbell Nebula show up here in the center now. This is the remnant of a star that has died. And what's left in the middle, you can see this tiny dot in here. You've seen this before, Keith. As we take an exposure, that tiny dot right there, that's a white dwarf. Now, this is thousands of light years away, so we're seeing it thousands of years ago. All right? Light is the fastest thing we know moving in the universe, and it took thousands of years for that light to get here. And even so, we can see that light of that white dwarf in the middle of that planetary nebula that we're seeing here. And that planetary nebula being a couple light years across, that white dwarf is only the size of the Earth. Yet thousands of light years away, we still see it brightly. And even more brightly when I take a 20-second shot of it.
It's pretty.
It's pretty. It's pretty indeed. So 20 seconds in, we'll get a good shot, and I'll make sure we've cleared. So we're all set here. There's our progress bar right over here. You watch that yellow bar reach the end, and our exposures are ready. That's the thing about SkyTour Livestream. We don't have to take half-hour shots and 15-minute shots. We set a telescope up to actually be very, very fast. And it runs 25 times faster than the scope was in its native style. Okay, so let's color correct. And now what we'll do is we're actually going to drill into the nebula a little by actually reducing the brightness in the center. Now you see that. Look at that. There's that white dwarf. Isn't that great, man? Check out that white dwarf.
I just figured out why. Because usually I pull the stream from the share screen on Skype. That's why.
Yeah.
Totally forgot about that.
Oh, so you can go fix it?
No, because you're not sharing the screen on Skype.
Oh, I could.
No, that's all right. We're good. That's pretty.
Yeah. That is just beautiful. Yep. Oh, yeah. Wow. So, here's what happened. This is right here. This line you see right here, that was the equator of the star, and the star was rotating on that angle that you see right there. So, to show you correctly, it was rotating on this angle right here. Okay, right through there. Okay, so when it was rotating like this, right, material went out here, material went out down there. Okay, it went on either side of that, and you'll notice that there's these arcs of material. And I think, and the chronology, I'm not sure about the chronology, but I think the star is precessing as it was doing that, meaning that it was wobbling on its axis, and so that equatorial belt shot out a lot of stuff, and this is where it happened to be when the light left it several thousand years ago. Okay, and there's that beautiful white dwarf right there. Yeah, look at that, huh?
I like the red on the edges.
Yeah, that red on the edges is hydrogen gas and possibly neon. But this
How dark
bluish...
that one spot.
Oh, I know. This down here?
Mm-hmm.
Yeah. Yeah, this nebula has very interesting characteristics in it, you know? Just crazy stuff. And we're actually, right now, we're actually at 175% of our sensors, so we're actually magnified. If we go to 100%, this is the native size right here. That's the native size of our sensor. That's cool, huh?
Mm-hmm.
And there's more out there. There's more out there too. I mean, if I actually just, where'd it go? Okay, come here. It vanished. I know, right? There we go. We get it back. Okay, I want to zoom in again because I want to show you this. Okay, so now watch. If I actually bring this up a little higher. Okay, we can come over here and move this a little bit so we reduce our black level, and it'll show us fainter details. And you can see there's more stuff out here and out here. We're capturing an awful lot in this nebula, and what we can do is accentuate it even more by squishing these together. This is called pushing the data. All right, so we can push the data to the ultimate extreme. That's right. All right, and this will make it much more viewable. Look at this arc right here. That arc is right there, and you do have to overexpose in order to get all this detail, you see. So it's pretty cool. And Izabela, is Izabela here with us?
Mm-hmm.
Yeah, there's Izabela. Hi, Izabela. Izabela is amazing with Skytour Livestream. I always have to tell people, because she'll take it upon herself to write our table of contents. She does processing. I've been teaching her what I know about processing. And she's doing what she's doing now. She's putting up the address of our, in the chat, she's putting the address of our database and everything. So she's really incredibly diligent about that. And she's an amazing asset to what we do. So thank you, Izabela, publicly, as always.
Thank you, Izabela.
And Keith will sing to you at night, Izabela.
La, 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 la.
Or not.
That. Or not.
Or not. Oh, hi, Keith.
Oh, hi, Mark.
Yeah, you can't play that now. Haha. Well, actually, you can on the other stream. So let's pull this. Now, look at how these other envelopes of oxygen have gone. These oxygen gas have gone out. You just did it, didn't you?
What's that?
You just played it?
No.
Oh, okay.
I can, though.
No, it's okay. Actually, you could play it through your speakers and everybody would hear it.
I don't know if I can. I don't know if it would be visible. Let me see here.
All right. Look at this.
Let's see.
Imagine being inside this, guys. You'd move into a region of space where there was a dull green glow all around you, you know, for light years. And you'd notice that the overall temperature of interstellar space near you would be much, much higher, you know, hot enough to ionize oxygen atoms. So we're talking about tens of thousands of degrees or more. This white dwarf, and most of the energy of this white dwarf is being given off in the ultraviolet range. So ultraviolet energy, short, high energy, high frequency, is going to ionize very easily. No luck there, Keith?
No, it's on a different, what you call it? Life with OBS. What can we do?
Yeah.
What I can do, actually...
I'm going to increase the sharpening here dynamically to see what it can do for us. See, we're actually bringing out details here now by doing that. It might increase the amount too, so it can get crazy bad. Let's just try it. Yeah, that was too high. When we do other processing, we actually remove the stars and then work only on the nebula. You just played it and heard it, didn't you?
I did.
Yeah,
It barely comes through because the volume is so weird.
Okay.
But
Cosmic Ray says most carbon stars are red giants. Yeah, actually, they are, and the reason that and what a carbon star is a star late in its evolution that has dredged up this material from inside, mostly carbon that was made in the core of the star, brought it to the surface, and it is like a soot. And the thing is, that takes a long time because these stars are red giants. They're big. If you put it where the sun is, the star could be as big all the way out past the orbit of Mars. So imagine how long it would take for material to come out and make its way to the photosphere, that is the visible star surface. But it's mostly this carbon soot which reddens the starlight, and that's why carbon stars are just stunning orange. Maybe tonight we could see one. I know that there's one up in the northern sky. And let's go see if we can see it at this point. It's going to be up here. It's up near here, I think. I'm looking for it now. Might be. I'm having a mental block on the name of the star because I know it well. I know it well. Well, I'll think of it. I will think of it. All right. What's that?
No, that I'm trying to do a workaround for audio.
Okay.
So I'm still kind of just quietly working in the background.
Okay, you just keep doing that.
I'm gonna keep doing it.
Let's get this. Let's get this out of here for now. Yeah, let's get the settings here. Let's auto set the settings, see what it wants to go to. Oh, look at that. It wants to show all that material out there. That's beautiful. Okay, that's beautiful. Yeah, that's really pretty. Okay, we've stacked 32 of these. I think it's time to call this one quits. And what we'll do is Dumbbell Nebula.
Still looks beautiful.
It's a PN, or a planetary nebula. All right, and it's also known as a Messier object. Messier, Charles Messier, cataloged it back in the 1700s. And they were called planetary nebulae, even though they have nothing to do with planets, because they just appeared about as bright in a small telescope as a planet and looked like you could mistake them for planets. And so these are, planetary nebulae. It's also known as Messier 27. Charles Messier cataloged it as Messier 27.
Messier 27.
Marson, thank you for the thumbs up. Okay. So now that we pause this, we're going to save it. This is the raw stack we just saved. And now we're going to save it exactly as seen. So now this image file, just like you see it, will be saved to the database in seconds from now. Okay. This is great. I'm glad we're getting some time tonight.
Right?
Ah, I heard it. I heard it.
I think we're getting there.
You're getting there. Uh-oh, it's getting better.
Is it?
Oh, hi, Mark.
There we go.
That's
Now we're
funny.
getting there.
That's
See what I did is
funny.
I put the Skype through my headphones and then linked that to its own channel and then did the desktop audio into another channel.
Oh, I'm sure. Oh, hi, Keith.
Oh hi. That's how great it is.
Yeah.
Oh, hi, Mark.
Oh, that's even better.
Right? We're getting there.
Yep.
We're technical marvels here at the Sky Tour.
Yeah. All right. Now that we know that this is the Dumbbell Nebula, I can pull this out and go to the next object. And I'd like to see. Let's see if we can find this object that I want to see here. Is this possible?
Oh, hi, Mark.
It's getting better. You know, you got to tell people what they're looking at. You know,
You're looking at a nebula.
No, I don't mean that.
Oh.
You gotta tell them. You gotta tell them a little bit more about the background of what they're hearing.
Oh, hi, Mark.
Exactly.
If anybody that doesn't know, that is from the movie The Room, one of the worst movies ever made, but
In
also
fact,
one of the
it's
cringiest,
true.
funny ones.
It is cringy. It is cringy funny, no
Yeah.
doubt.
Yep, and that just it seems to fit Mark very well. Whenever we want to
Being
join
that's my
in with Mark,
name.
Oh, hi, Mark.
and that's how we greet one another.
It's true.
It is very true.
All right. Now let's see if we can do this. We're gonna see if we can go to this carbon star and show it. You can't miss it when you see it, though. So here we go, and we should blast off, and there we go. We're blasting off, and we're gonna go to. I just want to show you when we talk about carbon stars, because Cosmic Ray mentioned carbon stars. Well, I think that makes it a good reason to show you one. They have a brilliant red color that is unlike the red you normally see. And Martian, yes, exactly. We're going to be doing a carbon star right now. It's called U Cygni. It's actually right near the Dumbbell Nebula, sort of. Next constellation over. You'll notice a telescope up there. It's pointing almost straight up. All right. Now look for the red star that comes in. I don't think you can miss that star right there. That is a carbon star. Look how red that is against all the other stars here. You know? I mean, this is a bit of an orange star, but that is a seriously red star.
It all looks green to me.
Well, that's of course because we are in night vision mode. If I turn off night vision mode, actually,
Right.
you can still see the star. And I'm zooming in now. Egad, that is just really annoying.
That's it's an attractive laugh, isn't it?
Yeah. Sort of like Peter Griffin laugh.
Yeah, right.
Peter, get out of the clothes.
Right.
Oh, Lois. All right, so there we go. So that's a carbon star. Let's do a 8-second shot of this carbon star, and then live stack it, just so you can see it. Okay, we're gonna clear this.
Clear it up.
All right. Now watch. Here comes a carbon star. Right here. Okay. Now let's just give it some coloration. Oh, look at that star. Look at the difference, huh? Let me also color balance. Boom. Okay, for Martian and Cosmic Ray, this is a carbon star. All right. Again, it's a star. It's a red giant that has a carbon signature in its outer envelope, okay, which is quite significant. You can see a faint nebula here, by the way, because we are in part of Cygnus where there is lots of Milky Way and other faint wispy structures. This is actually quite pretty, you know, quite pretty.
You know, and anytime anybody says hi to you, that's what you're going to hear. That's your new prompt.
Okay.
Oh, hi, Mark.
So if somebody new comes into the chat,
Hi, Papa Tom.
you'll hear that.
Yep. Yeah. Well, you know what? I mean, you know, we know our stuff, right? So if you ask for certain things, I can find some of those things. Let's zoom in.
Andromeda.
That's coming up. We saw that the other day.
Yeah. Damn right.
This is 220%. Look how red this is compared to like these red stars. Okay. Very, very red. Okay. And what I'm going to do right now is I'm going to stop the stack right now and I'm going to clear it. And you're going to say, why are you doing that? Because I'm going to do something else to help us out here. I am going to go through our autofocus routine, which some of you have seen, but I'm going to go into night vision mode. And now we're at 8 seconds. I'm going to go back to 1. Okay, there we go. And in night vision mode. And now what we'll do is I'm going to go into tools and I'm going to do a focus. All right. And so I'm going to go into multi-star full half width and I'm going to defocus the stars a little bit. And you'll notice that they're defocused now, and we're going to scan inward, and it'll pass the point of focus and then go out of focus again, and it's going to make a curve, and inside that curve we will get our perfect focus. So here we go. It's done its first focal point, and the stars will be getting a little bit smaller each time, a little bit smaller until they go into perfect focus, and then they're going to go out of focus. And what that does is it allows us to build up a curve. So you'll see this curve start to form right there, and then they'll start going back up. And then where it starts to go back up, the center point, the lowest point of that curve, right, you'll see a second line appear, and that will be the line of best focus. And as you can see, it's already starting up. So it's probably going to appear right about here. There it is, just like I said. Okay. And it's about halfway through. And then it draws a line of best fit through our points and finds our best position for focus. All right. So it comes from out of focus where I moved it, scans in, goes to the out of focus position. And now we're all set because the green bar up there says so. And now we go to best focus. Watch this. You're going to see the focus come across here, all the way to the far side, go out of focus, and now watch, it comes into focus right now, and now our stars are perfectly in focus.
Oh,
That's
hi,
what.
Mark.
There you go. Right?
Yeah.
Okay. Now I'll do this again. I'll do another 8 seconds and stack it, because that's all we needed. All right. So Keith, this is very different from what you do on P and K.
Very.
But you know, it's exciting. Whoops,
Yeah.
I left that going. Okay. Do you notice how the noise, every 8 seconds, the noise, this noise in between the stars goes away. With each new exposure, it gets smaller and smaller. And we get less and less noise. I love this faint wisp here of nebulosity here. That's
I'm
really
about
cool.
15 seconds behind of what you're talking about seeing it, just so you know.
Oh, well, that doesn't have to be the case. You know why?
Why?
I can share my screen. I have the bandwidth.
There we go.
Yep.
So I can put this down.
There we go.
And then I can move this over there.
Okay, now you got it. Now you're right on time.
Well, now I'm trying to...
It's a Skype shared screen.
Yeah, not sharing. So you know.
Well, I'm seeing.
I do have it open. I do have it open in a full screen, and yeah, nothing.
Nothing?
Nothing. Unless you want to try it again.
I will. I've stopped, and now I'll start once again.
Try. What's this mean? Oh no, they keep updating everything.
Yeah. All right, I started the show again.
Okay, there it is. I had to click the little button at the top that says "Go to call,"
Okay.
which is weird.
Stupid.
But okay.
Now you don't see me. You don't see me in the OBS screen. So if you did, you'd see this. Okay. Now, do you want to see the OBS screen, the broadcast screen, or do you want to see the actual?
I want to see what you're looking at and what you're talking about.
Okay. So do you want me to? Okay. Do you not want? Do you want to see OBS or do you want to see this?
Either one, whatever works for you.
Well, you won't see any of the labels I put out there. That's only.
No, this one's fine. This one's good.
Okay. Okay.
Yep.
All right. Well, there's your carbon star, guys, and I'm going to actually make a note of that and save it because it's cool to see these. Okay, it represents a specific star evolutionary state on the asymptotic giant branch of stellar evolution. That's the AGB, and it's called U Cygni.
U Cygni.
Yep.
Sweet.
And it's basically, it's a red sooty star. Put that out there.
How's it feel now not to have that 1 second delay?
Oh my gosh. It's real time, you know?
Yeah.
Look at the satellites that came through here in a very, very tight pair. You see that?
Mm-hmm.
Several of them. Wow. Oh yeah. Okay, well, we've done 24 of these. That's more than enough. And we can move on to the next thing if you wish.
Yes.
So I'm going to pause it and save it. That's going to go... let me change this, actually. Carbon star U Cygni. There we go. If anything's spelled wrong, I'll correct it on the server. Okay. So we'll save it now. Here we are. And then we will save exactly as seen. Baby cakes. All right.
Baby cakes.
Now we'll clear it. So how have you been, man? What's going on? Talk to me, man. I
Busy.
haven't talked to you in a while, brother.
Busy.
Yeah, what you doing?
Working. Nonstop. COVID.
You working COVID?
Yeah. For the last week.
What's that mean?
It means getting over COVID the last week.
Oh, you had COVID?
Yeah.
Oh, so a cold,
Barely.
basically.
Yeah. Barely.
Mm-hmm.
Still sucked. Don't get me wrong.
Yeah. And there's a person in the group called Carbon Star. That's a great name. It says censor noise from the camera, I would assume. You must have made a previous statement about that. Yeah, T. Leary, Carbon Star as well, yeah. Okay. Hey, Edward, how you doing? And Suzette Bavier, how are you? And we've got Dankfest0311. Good to see you.
Mm-hmm.
Bullwinkle is here with us.
Bullwinkle.
That's right. Hey, Rocky, watch me pull the rabbit out of my hat. Nothing to perceive. Presto! Must have had the wrong hat. Great name. Great name. All right, let's pull that out. Okay. And let's bring up our planetarium now. And now that we found that, there's a beautiful nebula up in this northern sky that I want to try and get to. And I think we can do it by going right here. There's a bunch of things coming up, and we're going north because in the south right now, that's right, Bullwinkle. Oops, I must have had the wrong hat. Oh, hi, Cindy Murphy. How you doing? Okay. Izabela says everybody had COVID but me. Are you jealous? You begin to feel left out?
Right.
No, I had COVID, and it was a cold, and nothing more.
Oh, hi, Mark.
Okay. Yeah. Oh, you know what? Yeah, there's some good things here. Okay. We're gonna come up to the elephant's trunk and check it out tonight, see what it looks like. There might be something different, you know, we never know.
Never know.
That's right. Alright, here we go. Okay, off we go. And there we are. High precision slew takes place. It's going to be way toward the backside, the backside of the observatory. It's going to be aiming out, and it's going to go to one of the stars nearby. All right, and it's going to tell you which one. It's going to be one of the stars in Cepheus.
Wah. Wah.
Zeta Cephei, right there. There it is. Yeah, and we'll go into night vision mode here. And I'm going to go into auto mode because this nebula is huge. It's huge and it's stunning.
It's massive.
It's quite large. It's beauteous. Uh-huh. Uh-oh, this guy may come in for a bit.
Yeah.
Maybe not. We'll see.
That would be dank.
Yes. Okay, this is the Elephant's Trunk Nebula, and it's right here. And I'm going to move us up just a little bit so that you can have more view of what's above here, because there's some beautiful dark nebulae up in here. But this is a 1 second exposure, and at this 1 second exposure, you can see indications that there's a nebula in here. It's just not very obvious, right?
Yeah.
Well, why don't we make it obvious, shall we? We are looking at our guider. Our guider is now guiding. That's what these numbers are. That's the percentage guiding corrections. And I'm going to make this a 25-second shot. Off we go. We're going to come out of night vision mode in a minute, and I'm going to go into the stack, and that's cleared, and now out of night vision mode so it doesn't get overblown. Night vision mode really amplifies the light tremendously.
A little bit.
Just a little bit. Watch this, guys. Ready? Here comes a gem. Pow. Doesn't look it, but give me a moment.
Looks like COVID.
Looks like COVID. We're dealing with moonlight. Okay.
Yeah.
So here we
Shut
go.
up, Mark. Don't talk about COVID.
Ah, look at this. Beautiful dark nebula here, and this nebula here. Oh, really stunning. And we're at 44%. We should view this at full aperture size here. There we go. Now, the other thing to do to really make it stand out far better is to do a color correction here, get our curves lined up. And now look at how much stuff is here. Now you can see a lot more. Oh, this nebula is just so beautiful. And let's zoom in on the center here, because I want to show you. Yeah, you can't really see it yet because we have to allow the stacked images to show more detail. But look at the two stars in here. This star has created kind of a hole in this here with its stellar winds pushing out, have kind of emptied the core of this part of the nebula. And then there's another star that's in the dust and looks very red right here. But imagine if you were there, what it would look like, right? It's just incredible what this looks like here.
I don't know, if we were there, that'd be a whole different perspective, wouldn't it?
Yes, it would. You would not know you
Yeah.
wouldn't know you're in the nebula until you took pictures of it.
Right.
You know. Okay, so now let's try a little something. And Izabela says, "Hello, Elephant's Trunk Nebula." Yeah. Okay, we've stacked 5 of these. Again, we did 25 seconds. I've actually exposed this for up to a minute. It's beautiful. Now, this area
I do.
is...
Izabela, just so you know.
Pinky, do you see this, chat? Oh, yes. Look at that. Wow. Okay, we have the elephant's trunk is this formation right here that kind of looks like an elephant's trunk. Then this right here it looks like a camel with its humps. Okay, so it's called the caravan. So maybe these are what, Bactrian camels with 2 humps, or dromedaries, or is it dromedary have 2 humps? Which one
this
has
is your
2
specialty.
humps? I don't know.
Bring the moon, I'll tell you whatever you want to know.
Yeah, that's true.
Space humps, I have no idea.
Yeah, okay. Well, fair enough. And we have a satellite moving through, as you can see here.
Yep.
You'll notice this filamentary structure. This is beautiful filaments here. We can actually push that a little to bring out some more of that detail. Look at that. Maybe add some contrast, darken the background a little bit. Yeah, there we go. Yeah, look at that. Beautiful. Isn't that amazing? That is just such a beautiful nebula. If anyone has any questions, feel free. Toss them at me. And Keith.
Yeah, that's a...
It almost looks
very
3D.
interesting. Yeah. It does have that kind of quality to it.
Yeah.
It's almost like a trick of the eyes.
Yeah. And, you know, it is... It is a 3D universe, and we don't really know, which way it's going. We don't know whether that's like an angular thing coming out at us or something that's going away from us. You know, I don't know if they've done any studies to show that with this. They might have. They might have. Martin Johansson says, "Curse you, Starlink. That satellite. That wasn't the Starlink satellite. Starlink satellites make bigger trails." Okay. Yeah. But I will say this, Martin. Starlink is why you see this at all today. We are connected via Starlink to the internet, and we now have streaming speeds that are far higher than we had before. So this is far better. So yes, as astronomers, we have problems with Starlink, but Starlink also brings us the night sky. So can't complain too much, right?
Yeah, it's a give and take.
Yeah. Papa Tom, thank you for coming out, and we will see you on the next one.
See you later, Papa Tom.
Yeah, thanks for coming out. All right. As you can see, as we have got 13 stacked now, we see more detail and things look more clear. This area now, when we zoom in, you'll notice there's a little bit of a blue halo around it, and that is indicative of something else going on here. Okay, you see this blue now? This is more of that reflection nebula that we call it. And this reflection nebula, again, as was pointed out earlier, is due to Rayleigh scattering that we talked about and that was mentioned in chat. Was that you, Marson, that mentioned it? I think so.
I believe that's when I was figuring out the audio, but I didn't remember you saying something about it.
Yeah, that's okay.
Mm.
So how tired are you tonight?
Not too bad. Why?
No, I'm just asking.
I'm sitting back enjoying the views for once.
I know, right? Isn't it great? So going through here, look at these dark nebula. These beautiful snaking dark filaments. These are my favorite spots in the universe because these are the fundamental, foundational places where stars and planets will be forming. When they actually do form, well, they illuminate and they illuminate nebulae by having their light scattered, but they also create these beautiful diffuse hydrogen glows of hydrogen gas that's glowing. Right? So those are created by the stars, but this entire region started as a dark nebula. And once a star was born in there, it lit it up blue, or it ionized hydrogen gas around it, making it red. So we're seeing this after this cluster of stars was formed in this region. And what happens is these clusters of stars, they core out or open up the center of the nebulae with their powerful stellar winds. So they actually push away a lot of stuff. And as you can see, this certainly looks like a hole, doesn't it? Now, yes, there's dark nebulae in here, but there's also areas where you don't see hydrogen gas glowing so close to the stars. You figure, well, we'd see it all throughout. In some nebulae, we do. But here, the hot young stars have probably pushed a lot of that hydrogen gas away over time. And it's probably the reason, in fact, why this looks the way it does. Okay, because we have these hot stars, energy is striking this dark nebula area. This is dense, and so it's hard for that to be evaporated by the star's stellar wind, and so what's behind it is protected, and then it gets back here, starts colliding with things, and starts whittling away at the back end. That's perhaps what's happening there.
It's such an optical illusion because everything looks so close.
Yeah, well, it does, doesn't it?
Everything looks so close, it makes it look like it carved a path out, but if you were there, you wouldn't even be able to tell.
Yeah, you're right. It's like clouds, right? Clouds look very sharply defined until you fly into them with a plane. Then they're soft and you're in them and then you're out of them and you go, wait a minute.
Mm-hmm.
The hard edge is softened when you're near it. Look at this beautiful, beautiful cloud. Look at that. One of the universe's most perplexing, dangerous places. And it's true. The universe, everywhere you turn, the universe could kill us.
Yep.
If only.
And it wants to.
That's right. And it wants to, yeah. If only for a tiny shell of air around this rock for us to survive on. So it's pretty fascinating.
When you think about it, everything really just had to fall in the right spots.
That's right.
From our little planet here with water and air to our big protector Jupiter to crazy. Just that Goldilocks zone.
Yep. The not too hot, not too cold region where water could exist in liquid form on the surface.
Yeah,
that's right.
And you would think that would be like special, but then you look out at all this and you're like, okay, this probably happened again many a times throughout all this.
And that's precisely the argument I make, which is, relates to the title of my book, right? The Populated Universe.
The Populated Universe.
Meaning that I think life in the universe is the rule, not the exception. And I think it has to do with the fact that carbon, of which we're based, carbon-based, is the fourth most abundant element in the universe. Number 4, next to oxygen, which is next highest in abundance, helium and hydrogen. Huh?
And ignorance.
Oh yeah, right.
It's one of the main elements.
We have a abundance of the element of ignorance when it comes to science out there. You know?
Aluminium.
Well, that's how they've always said it. It doesn't mean it's wrong.
Nope. That does not.
Beautiful region. Let's try and get some. Let's get some contrast here. Let's push this a little. Oh, look at that. That's looking 3D. And let's darken it up a bit.
Still looking at the clouds in the back radar. Like I'm watching them slowly creep. I'm like,
oh yeah.
Stay away.
Creeping. Yeah, they look like they're going down under.
Where's the
This is the observatory.
Okay. Yeah, they're staying to the south. So far, so good.
So far, so good, yes. I was just showing Keith the weather. Okay, so now we actually have better contrast. Look at this. Stunning view. Oh.
It's
really
like
stunning.
Interstellar highways.
Yeah.
Junctions.
Amazing. Yeah. See, now the elephant's trunk and the caravan, this area now is far more well defined. Look at that. Look at that. You can see all the separate little strands in here. Oh. Wow.
Yeah, I'm seeing the one on Skype. It's not as clear as the one on YouTube. The one on YouTube is just bow.
Yeah, the one on YouTube is 1080p.
Yeah.
Yeah. In Skype, it's a little bit. Yeah, the Skype is a placeholder, so you see the real time.
Oh, hi, Mark.
Oh, hi, Keith.
I know, that was JSCO.
Oh, JSCO 77. Hey, how you doing? Uber Crew's with us too. Hey there. Asher Real, how are you? Good to see you.
Here we are looking.
Asher, and I responded positively. I sent that back. I said, okay, yes, let's do the friend thing in Facebook. Wow, look
As
at
we
that.
sit here and stare at COVID.
You're right. You know what's funny? It's like, even when I had COVID and I was just trying hard to get over it, I couldn't wait to get behind the controls of this telescope again.
Yeah.
And even sick, I had to go out there and attach and just open the roof and shut the roof. Open the roof and shut the roof.
Just to get your fix.
Because I could, you know? Because I could do it.
Yeah.
Yeah.
I get it. You know, it's exciting.
Yeah. Well, it is because, you know...
you work so hard for it.
Yeah, you remember how... Yeah, we worked hard for this. There's no doubt about it. You remember how
a long trip to Arizona.
Yeah, that's right. You drove it out there. And by the way, let's give you credit. Folks, I don't know if you know this, but this guy, Keith, from P&K Space Imaging, who's on us with us right now, he's the one that's the reason we have these images. Why? Number one, he convinced me to start streaming. Okay? He was one of 2 or 3 other people, you know, him, Paul, and Bill, New York Skywatcher. Okay? Second, he's also the one that drove this entire telescope system from here in Connecticut, where it was already installed in our actual dome building here, all the way to Arizona. Now, you talk about someone who is willing to do something. He did it for probably half of what he should have gotten for it. But he
that was
did
a long
anyway.
trip.
It was a long trip. I think
That
he's
was a
still
long
asking
trip.
for more money, too.
I was literally at Mary Ann's for like an hour and a half. Like
That's
from
your
Pennsylvania to Arizona, in Arizona for an hour and a half, turn around, come all the way back.
Yeah, that was crazy. You should have stayed more than that.
Well, we had to get back. There was no other.
Well, she wanted to show you all kinds of things when you were there.
I know. We'll have to get out there though. We'll get there.
Well, when you and Siobhan do get out there, then we'll go kayaking in Canyon Lake. We'll go out and you should participate in the boot camp, and
we'll get dehydrated and visit the hospital together.
No.
Yeah.
Well, as you know,
learned your lesson, did you?
I did. Yeah. That's a story and a half. At Marianne would love to say, "Hey there, Maya Leone. How are you?"
Maya Leone.
Good to see you.
Welcome.
Hi, Mark.
Yeah, please subscribe to us, and if you haven't, I've seen you before. I think you've been on Keith's stream, but I haven't.
Possibility.
I don't remember seeing you here, but now I'm glad you found us. Look at this. This is getting better. I can't stop looking at it.
Sticky cactus balls.
Oh yeah, those are the wonderful choyas. It's almost like they're alive, and they find you and say, "Go for him."
Yeah. Yeah.
Go for Papa Choya ball.
Gotta get it done. By the way, are you doing a live show this week?
No, because of the holiday.
Oh, okay. Yeah, I didn't know if you were or not.
Yeah.
Do they just replay your past show this Sunday?
We have hundreds of shows to pick from, so it's not a problem to
really?
to
Have you done
replay
hundreds of
whatsoever.
shows already?
Yeah.
Wow.
I have hundreds of streams too up there.
Yeah.
Yeah, you have way more than that.
Oh yeah, we got like 400, 500.
Yeah, we're at like 300 and something up there.
I kind of think about like when we started, we're ridiculous. Like when we first started streaming, it is like when we first started streaming, we would start. Okay, I think we started like in the fall, so I think we would start at like 6:30 at night, and we would be streaming until 2-3 o'clock in the morning.
I remember that. That's right.
Night. And then both of us get up and go to work at like 5 and 6 o'clock. Come home, grab a little sleep when we got home, and then stream again.
Yeah, you and Paul were crazy.
Gee, I mean, we were doing 6-7 hour streams every night.
We know what this is. I'm just gonna pull that out for now.
It's like, what kind of mental patients were we?
Well, you see the value of it as well. You provide.
We wanted to catch some UFOs, is what we wanted to do.
Yeah, and then you have me on the stream, and we get all disappointed. I calculate that's at an orbit of 290 miles based on the size of the path and how fast it covered that's the intervening space. Blah blah blah.
Moon math.
Moon math.
Yeah.
Marson asks, "Is monsoon season over with Arizona?" Yeah, it's yes. Be quiet.
No.
It's almost on. It's on
2 more
the wane.
weeks.
No. Does this look like 2 more weeks? Okay. I mean, the only reason that we have some clouds now actually has to do with this cyclone off the Baja coast, and a few of the clouds are coming in, and they're getting close.
They are. They're creeping slowly.
Actually, that looks closer than it really is. I mean, if you think about it, there's got to be almost 20 miles in there.
Ladies and gentlemen, we're watching a radar that you can't currently see, but trust us, the clouds are creeping right up from the bottom. We might have to go ahead and run for our lives.
Well,
even though you're in Connecticut and I'm in Pennsylvania and the scope is in Arizona.
I mean, there's no reason I can't show people this.
Yeah.
There it is.
There you go.
See, guys, this is it right here. This is the observatory. Okay, and there's the clouds. And if we back out a little bit, you can see down here, you can see that there is a cyclonic storm down here, right there, heading that way, northwest, and it's pulling its clouds, and the collision of this front here with this obviously weather front is causing this rebound effect here, sort of thing. And so we're getting clouds, but I predict that these clouds will probably come in and finally ruin us, but that's okay.
Oh, hi, Mark.
Oh, hi, Keith. But there you
Yeah, they might ruin
Yeah.
us.
go. Ah, but they'll be all
Hi, doggy.
right. Oh. Wow.
Yeah, look at that.
Look at this. It's so deep in here now. This is actually, I have to say, this is probably the best picture of the elephant's trunk we've ever taken.
Right?
The detail is quite stunning.
Mm.
Izabela, you're going to have a field day with this. She does processing as well as I do. And there's just so much here worthy of processing.
That's huge.
It's massive.
Yeah. It's a number of light years in size for sure.
Mm-hmm. Mm-mm-mm.
All right, I'm labeling
How
up
many
here,
frames
and
is that?
Emission nebula, EN, hold on, and DN for dark nebula. Okay, down here you can see we've stacked 51 frames. It says right there.
I was trying to see it, but it was blurry.
Yeah, but we can also look here and see it.
Let's see. It's a little bit behind on YouTube, but kind of the same.
Yeah, 51 frames, just beautiful. Wow.
Just super.
All right, well, we'll stop now and pause it. And we're going to save this now. And it's going to save it to the Elephant's Trunk Nebula. Okay, it's been saved. And then this, just as you see it, I'll save it. Okay, save exactly as seen. Right, and there it is. Let me show you what you're getting, though. If you go out there and just download it, okay, this is what you're getting. This is the entire image. And obviously this section here is what we're just focused on, right? But look at that. That is just beautiful. And the nature of our sensor is such that we can literally zoom in quite a distance and still, or quite a lot actually, and see an awful lot of detail in here without going and losing the detail. I'll show you right now. Let's zoom in on the head of the elephant's trunk right here. All right, we'll come in. All right, this is 156%.
Yeah.
Right? And look at this nebula. This is a little blue reflection nebula here that is tied to this star, which is scattering the light in this dust cloud, or the dust cloud scattering the light from the star. And these two stars are actually causing the hydrogen gas in here to glow, probably out here as well. So there's a lot going on in there, but it's just beautiful to see this. Wow.
Oh, hi,
All
Mark.
right. Yes. Somebody else?
Well, that's a very interesting story. When I moved to San Francisco with 2 suitcases, I didn't know anyone.
Hey, C&D boy.
C&D.
Yeah.
I know, it's crazy how many stars.
I know it, man.
Hmm.
Yes, and if you think of it this way, and Lee Spiegel likes to say it this way too. Lee Spiegel is a good friend of mine. He used to run one of the desks at Huffington Post, or actually had a blog. Well, Lee Spiegel used to say, every one of these stars are suns. And for him, that helped him to point out that planets could exist around the bulk of these stars. And they do. Hello, Prow. Hey, Zadarak. Hey, City Lights. Wow, it's good to see you guys.
Coming in groups.
They are. I love it. This is very nice. I'm glad you guys are here. Okay, there's 45 of you watching right now. And it's fun to have you here. Again, just so everybody knows, this is the Elephant's Trunk Nebula. It is an emission nebula, the red, and a dark nebula. The dark nebula is dust.
Quite a lot,
That's seen
can
only
see
by
an awful lot.
contrast.
Hmm.
Messing with your sound again, Keith.
No, I accidentally hit the mute button, so it unmuted.
All right. Wow. Okay.
Wow.
So.
I'm just seeing it on YouTube. Holy.
Okay.
That is a lot different than what I'm seeing on Skype.
Yeah. All right, I'm gonna save it again, even though I've saved it already.
Never can be too safe.
Nope. I always save more than I need in case. And we'll kill the stack, and when we come in, we can clear it after. All right. Let's maximize this brightness here.
Ooh, that's crisp.
Beautiful, isn't it? And now we're going to go to 1 second again. And go to night vision mode. And see what lurks back here? Look at that. Alright, let's go now and come back to here. So we've been looking at the elephant's trunk. And I would like to take us... There's another nebula that I want to look for. Oh yes, I'll get there this way.
You know, one thing I figured out from doing these streams all night with you,
What's that?
that we both really need to grease our chairs.
Oh, well, yeah. Oh. Flaming Star Nebula is not up yet. Okay, can't look at it. That's okay.
Andromeda.
It's right there, and so I was waiting for Andromeda to show up.
Andromeda.
Yes, would you like to see Andromeda?
Well, yeah. Andromeda's just sitting there, like, waiting.
All right. Well, let's go up and let's check the altitude. It's 35, 36 degrees up. That we should be able to look at that.
Oh, hi, Mark.
That was Andromeda calling to you.
Oh, okay. I looked in the chat to see if somebody else joined. Because you were doing that so religiously, it was perfect. Okay, and now we'll look at Andromeda's wonderful galaxy. Mm-hmm. And we're telling it to go now. And off it goes. It might use Mirage, but look where it's looking. It's going way down low. As long as you can see the star, though, we'll be okay. That's going to be the star it uses. And the building is in the way, but it should be able to find it, and then it's going to move up higher to see the Andromeda Galaxy.
Looks like it's in a warp bubble.
There it goes. Now it moved out. There we go. We got it.
Bam!
Yeah. Bam, 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 bam. Doesn't look like much, right? Until we actually, bring ourselves.
It's like that star looks fuzzy.
That's a fuzzy star.
That star
Isn't
has
that
hair.
fuzzy? That star is fuzzy, Chris. All right, so we're gonna move to the west a little bit now. And we're going to put it right about here. I think tonight we're going to do a mosaic. We do a lot of mosaics where we actually would take pictures to include the entire object because it's really difficult to capture the whole thing because it's much bigger than what we see. So I'm going to do this. And this. You get the lower half of the Andromeda Galaxy. And we're going to let the Starlock guide take over.
And we're going to do cutting and pasting.
It's not even that. I actually do compositing automatically with it. Which is really cool.
Composting. Love it.
Yes. So here we go. I give the telescope time to settle down. Alright, we're going to do a 25-second shot now. Oh yeah. And do our stack, and you'll see the elephant's trunk from before. Oh, look at that. Yes, it is. And it's up on the server already, probably. So if you go to skytourlive.com and scroll down, you can click that next heading, take me to the pictures, take me to the database, go to tonight's date, which is all the way at the bottom. The red means we're hitting the observatory wall.
Yep.
Okay. All right, Andromeda is not quite ready for prime time.
Not quite.
And what's funny? That red you see, this is how sensitive the camera is. The camera has a tiny little LED light on it that's red to show you that the power's on. And it's reflecting off of the observatory structure, faint as it is. You'd never see it with your eyes. And so we're seeing it that way. And that actually is a helper. It lets me know that we have something in the way. But anyway, while here, I'll do a adjustment so you can see.
Still badass.
It is, but it's bad. We can see individual stars when we get down here, and globular clusters too. And this isn't even enough.
One last night or the night before?
Yeah, we
it was
did.
Really good.
Yeah. All right, so we can't keep this because, unfortunately, Andromeda's not ready. But let's see if Measure 33 is ready. Measure 33 is back here. Or it might be lower. Oh, no, wait. I'm wrong. It's even further low. We gotta wait a while. Well, we'll get to it. We'll get to it. We will get there.
Cloud check.
Yeah, let's do a
I'm
cloud
going to have to
check.
keep an eye on that thing. Because you know what would be horrible? If, like, all of a sudden it got some moisture out of nowhere.
Yeah. Well, if we look at the weather radar, and don't want to keep people out, we'll just bring them in. Our weather radar is looking... Okay, the observatory's there.
Yeah, it's coming from the northeast.
Yeah. That's
It's
coming
moving
down,
pretty
but
quick,
it's,
too, isn't it?
but it's colliding with what's this other air mass. So I don't think we'll see that here tonight.
I don't know.
Okay.
It's moving pretty quick for 2
Yeah,
hours.
But this is, you're right. But these are going to collide.
Well, they already have.
Yeah.
That one up there is, you know, because you got to remember that other one's pulling way, even though it's pushing clouds that way, it's still pulling way to the northwest. So it's going to let that one kind of come in behind it.
See what's happening here? Look at the collision right here.
That's why you're going to get storms.
See where the collision's happening? Watch this. When these collide, this deforms. Look at that. It's bending. Okay, this air mass is bending under the weight of this weight, under the air flow of that. But I think that's still going to be good news for us, perhaps.
Hopefully.
We'll see. Yeah, we'll see. Well, there you go, folks. See that? Now you can see the weather, too. And I don't like leaving you out and just talking over your heads about stuff. So, I'd love to see the Heart Nebula, but I don't think we can look at it from here. I think it's too low. I think it's still just a little bit too low. Yeah, I'm rushing things, aren't I? I just want to see it. But you know what? There is something that we can probably see. Oh, I know what we can see. Oh, yes.
Dude,
This
how
can
have we
see.
been streaming from over here for an hour and a half already? It's crazy,
Time is magic.
right?
Okay, let's
It's got lost in a wormhole.
we did.
Seriously, it doesn't seem like it's been an hour and a half.
I know.
It's weird.
I know it. Okay. We're going to go to a nebula called the Iris Nebula. This looks like a flower iris. And we're going to take several shots of it. And I'll tell you why. The center is very bright. So we're going to take some shots to show just the center. And then we're going to take shots to show all the details on the outside. And then I can put them together and blend the lower exposure with the higher exposure stuff seamlessly, so you can actually see what the nebula would look like to your eye if your eye was sensitive enough to see this. See where the telescope's looking? It's going to be looking up in the air, almost straight up. There's the iris right there.
Chicka chicka.
Chicka chicka. Alright, so knowing what to expect here at this location, I know to move the iris over here. Okay, and then move the telescope south so that we can put that up near the top. This is an extensive object. It goes beyond the size of our field. This dim center is because we're doing an automatic subtraction to counter the sensor having a number of extra pixels that are light sensitive. Here it's like an averaging issue. Around the edges it doesn't do it as much, but here this is where most of the pixels will fall. So we counter by actually putting the negative of that in there, which is automatically, I did it automatically. All right, here is the iris. I'm going to show you something really cool. And I think tonight is going to be beautiful. So first things first, I'm going to do a 15-second shot of the iris. No, I'm not. I'm going to do a 10-second shot. Only 10. Get rid of this. And go into our stack. And hit clear anyway. Iris. I know you don't see it yet. And this is going to be a RN reflection nebula, DN dark nebula. Okay, now that we've done that, okay, now you see the interior of this nebula. It's very bright. And to see the rest of what's out here, we're going to have to go even brighter exposure, a longer exposure, which is going to then take this and blow it right out of the water.
Welcome to Asgard.
That's right. That's right. That's exactly right. There it is. This is, you can see it by looking at the fact that you can't see stars behind it. That's dust blocking the other stars behind it. So you see all the dust here, but you don't see it very well. Okay. To see it right, we're gonna just do a stack of 10 of these, and then I'll be able to bring them in after. But all right, so we'll just do 10. So 20 more seconds total, and then we'll be able to do a longer one, and then you'll see everything, and you'll be like, "Wow."
Amazing.
I think you will be excited. All right, there we go. 10. All right, and I've already got it named up here as the iris. We're going to save it. And save it exactly as seen. Okay. All right, now we'll clear and go in and do a 30-second shot. Okay, there we go. 30-second shot. And we're going to clear it. Now you're going to see something a little bit different. Izabela says, clouds are coming. Well, let's find out. Are they?
Oh, they're creeping closer.
Right, but we're looking up here. So we're avoiding them. That is going to shut us down, though. That is moving in pretty fast.
I told you that thing is moving, man.
It's zipping. Yeah, it's saying, he's streaming. Come on, Frank. We got to get in here.
Well, it's
we got to
also
stop him from doing this.
Full of moisture, so it's denser, so it's going to push its way through at least a little bit.
Yes, it will.
It depends on what the level of the...
Yes.
They're on, too.
Okay, so now our levels are all off here. Yeah, they're all off. But I'm gonna do a color correction, match up everything. Now you see our two curves are way off, so I'm gonna let it tell you. Now watch. Boom. Okay, so now we zoom out. Once we stack up some more here, all the dust that's in here will show. You'll see it quite well. Yes, sirree.
You think all the gods are just sitting around the universe going, these humans are we're sitting around here taking pictures of dust.
Yeah.
They're amazed by it.
And we'll like to name things.
Yeah.
Yeah. All right. Let's see. We have stacked 3 of them so far. Let's try to back this out a bit. Exactly. Oh, I can't do it. There we go.
It's that time of the night. Sound effects are inbound.
Yeah, right. All right. Oh, yeah. So there's dust there. No doubt. And that dust is extremely important to the universe. Marianne says, just got back. Talking about Mark's little trip to the hospital. They now have a wing at the hospital dedicated to Mark. Oh, yeah, that's just great. That's what I need.
Yeah, it's the room right next to the water fountain.
It's called the men's room.
Is that your indoor outhouse?
Yeah. Yeah. Ed Zachary.
Look at that.
Okay, let's increase the, now that we got 6 stacked, let's try to pull our dark level in here to darken up the background, but leave the dust brighter. Yeah, so you see we got dust throughout here. And we're going to let this develop. Wow.
It's amazing what dust can turn into.
Yeah, it's true.
Like planets.
Yes. That's where we came from.
Yep. We're just a bunch of dust balls.
In fact, this area of the universe right here, this was just a reflection nebula. All right. Well, it was actually just a dark nebula. And then when this star formed in here, it wasn't, there may be less hydrogen in here. And so what the star did was it blazed out into the cloud. And thus what ended up happening was the cloud with its dust scattered the starlight. You'll notice the interior is sort of open in here. That's because, again, the star has been scouring clear the interior with its powerful stellar winds. This happens with all these stars. They have powerful winds. You know the feeling of the radiation of the sun in your face? Okay, that's the ultraviolet and infrared radiation that's getting down to your face. Okay? You're also, in part, feeling a little bit of that stellar wind from our sun. It's called the solar wind. A lot of them are charged particles, charged protons and electrons that stream separately from the sun on out to our planet. But they're charged, so when they get to our Earth, they get trapped by the magnetic field. All right? And the magnetic field causes them to spiral down over the poles. Thus, we get from those Aurora Borealis, the northern lights, and Aurora Australis, the southern lights. David Schmidt's with us from Thailand.
David Schmidt from Thailand.
That's right. We have P and K's own Keith Ickes with us tonight.
Ooh.
Oh yeah, that's Keith. He's the man.
Mm-hmm.
He's the man behind. He's the magic man behind all the magic of
Magic man.
PK space imaging.
Oh, hi, Mark.
Yeah. I have to admit, I am getting tired though. That's because my normal bedtime's like 8 o'clock.
Yeah, you're an hour later than Marianne.
Yeah. I have to. I'm usually up
That's
at 4:30.
That's okay. We can cut this if we have to.
No, you can continue even without me. I'm pretty sure you'd be good.
I'm pretty sure, but I am looking at this storm, which is starting to close in. And it is moving pretty fast. Darn it.
I told you, dude. Didn't want to believe me.
Well,
I just saw the time frame on the bottom and saw how far it came in just that few. I was like, whoa.
yeah. I want to be able to give something to the people that are coming to the stream.
Well,
I'm going to remove the name
do it
here
old school.
because the name is detracting from the view. And we can also do this. We can pull the view over and just maximize the view for everybody to see what's going on. Okay.
Hello, Proficient Epic 300 from Chicago.
Oh, is that on yours?
Yeah,
Oh, wow.
that is on the P&K channel.
Oh, man. Hey, Proficient. How you doing? Oh, he can't hear me. Or
Yeah,
yes,
he
he can.
You just won't hear you for another 5 minutes. Yeah.
Kakang. Why not come over and subscribe to Sky Tour live stream over here? Yep. Roni, Carmen, come on over. What are you doing? Justin, what's happening? C&D boy, where are you? You over here too? Meow. Meow.
Everybody. We still got 20 over in P&K, so.
Boy, you're what's going on over there?
Oh.
Yeah, your stream looks pretty bad over there. Is that not? That's not how it really looks, is it?
No, it looks pretty good to me.
Okay.
You think your YouTube just isn't resolving it?
I don't.
'Cause I know yours did that a couple times. It was like blurry, and all of a sudden it jumped back up and cleared up.
Yeah.
No, it looks pretty good
You
on
can-
mine.
You can see this beautiful brownish cloud now of dust. This is what we see in this dust. It actually is not black. It's sort of a brown dust.
Huh.
And that's because it's made of carbon molecules, silica grains, and
Dirt.
these silica grains. Yes, exactly.
Space
These
dirt.
silica grains, space dirt. Yeah. Good C&D boy. I see you now. Space dirt, basically. These silica grains are copious. There's trillions of them, and they're only a few microns across. A micron is a millionth of a meter, so you can see how small these are. And what's interesting is notice this area right here. This is an area, for whatever reason, is devoid of any dark nebula, and you can see through it to the stars behind. You're seeing the background stars much further away. But then, notice as you get closer, you look at these two stars. These two stars are in this dust cloud, and their light is reddened in the same way that our sunlight is reddened on the horizon. More particles between us and the sun, more molecules of air, and it tends to scatter more blue light. And then when it does, it reddens the starlight that's left over. Hey there, Skunk Egg Farm.
It looks like it's such a small area from this far away. It's
Yeah.
crazy.
Isn't that neat? That's pretty neat. Wow.
Skunk Ape Farm.
Yep. The reason I did this also is because you can see up here, you see another little brown nebula that's forming up there.
No. Looks like a smudge.
It does. And it will continue to, unless I add the right amount of contrast to it just to show you.
Oh, hi, Mark.
Skunk Ape Farm Off-Grid. Good to see you, like I said. There we are. Cosmic Ray actually does a nice job of throwing in statistics about the object we're looking at, so I want to send out my kudos to him for doing that. Thank you. 1,300 light years, distance, spatial diameter of about 7 light years. Alice Pooper, our brown nebula, a small star explosion. That's Alice Cooper, right? Our brown nebula, small star explosion. No, actually, they're actually
brown
remnants
dwarf
of
Alice Pooper. Sorry,
yeah, you're always in that mode.
I mean, it does say Pooper.
Alice, it does. Alice, these brown dust clouds are not stellar explosions. They came from very large stellar explosions and supernovae, billions and billions of them over time. And that stuff has had plenty of time to migrate through the universe and galaxies and be brought around by gravity, tugged and pulled in all directions until it ends up in certain areas in space to form the foundational elements to create new stars and new galaxies. But that's a fantastic question.
Yeah. An even better name.
And as Cosmic Ray points out, this star you see right here may only be a few thousand years old. So this could have been just a brown cloud in space like this one until this star shows up, and then the dust clouds were scattering the light from it. Really nice. What?
I'm still giggling at Alice Pooper.
Oh, okay. Alice Pooper is one of our mainstay attendees.
I know, but the name is great.
Telescope. It is.
Yep.
Yes, of course.
You know my kind of humor.
Ooh.
Yep.
Wow, this is pretty.
Pretty damn gorgeous.
Yeah. So you see what it looks like. This is just a beautiful area of the sky. Let's soften it up and bring it out more. You can see the deeper densities of this dark cloud in here. Really something. And then we bring this down.
Asgard.
That's right. What do they call that? What do they call? You know, what do they call that? What's the gate that they go through?
The Bifrost?
Yeah, the Bifrost. That's right. That's right. He's gone through the Bifrost.
Bifrost. In theory, it can even summon the Bifrost.
I think it should be called the Bifrost.
I think it should be called Frank.
Well, yeah.
Welcome to Valhalla.
Yeah. Welcome to Todd.
Please see the Guardian of Asgard, the Keeper at the Gate, Alice
Step
Pooper.
Step through Todd, the Guardian of the Gate.
Yeah.
Yes.
Please see Alice Pooper at the gate.
Okay, we've done 31 of these. This should give us enough to play with this. Alright. Pause this. And I think I did the iris. Did I do this? I think I did this ahead of time. I did. Alright, so we will save this guy. Yeah, and save it exactly as seen. Still?
Yeah. I don't know why I think it's so funny.
Well,
Maybe I just got the nighttime giggles.
It's because it's almost 1 a.m.
Yeah.
Okay. Clear
Alice
this.
Pooper.
Yeah, it's a great name. We love it.
Yeah.
Okay.
And then you just add in the whole thing like Alice Pooper and Asgardians.
Well, yeah.
You know. It's
I didn't think
there.
about that. Yeah,
It's just there for the
Asgardians.
taking.
It is indeed. Okay, so this is night vision mode here with the nebula. Let's go. Let's see if we've given Andromeda time to get a little higher. Let's find out what's at altitude now.
No problem, Marianne. Have a great night. And we will be in contact.
All right.
Myself
Good night, Marianne.
and Alice Pooper. That's so wrong.
You just can't say Alice Pooper without throwing in that.
I don't know why that's so funny.
It's an automatic thing, it seems, huh?
Yeah.
All right. Well, let's get the Andromeda Galaxy here.
It was like that one dude that was in our stream. His name was Dick Hammerbush.
Wow.
Not as funny as Alice Pooper.
Oh, it's something else. Okay. And what if that was his real name?
What?
What if that was his real name?
Alice Pooper?
No.
Let's shake that man's hand. Or Dick.
Okay, here we go. Okay, now we're going to go to the Andromeda Galaxy. And this will be our last object for tonight.
Yeah.
Because I know you got to go to bed. And I have to also...
The wife's going to be like, why are you giggling on that side of the bed?
I know. It's
I'll be like, check this out. Let me tell you a story.
Why are you giggling
about this.
and why are you making that fake noise? I mean, why are you doing that?
Let me tell you the legend
Okay.
of Alice
The
Pooper.
legend. So, you know you got Alice Pooper laughing hysterically out there in digital space world, right?
I hope so, because he has me laughing.
Well,
Or
could
she
be a
has
she,
me. I don't
too.
even know. Yeah, it could be either one.
okay. I think we are above the observatory.
You're
'Cause
above
this
the
looks-
observatory?
Yeah, we're above the wall. We waited
All in
long
all,
enough.
it's just another picture above the wall.
That's right. Another brick in the wally wall. Okay. Let's just go. Alright. Now, it may be our last object, but I'm going to do it as a composite. Okay. So this is going to be the bottom half of Andromeda. Alright. And I'll go back north a little bit, just a tad. It comes way down here, so it's pretty big. Okay. We'll let this catch up. Let this see. We need about 12 seconds for the guide star to latch on, so you'll watch right up there. It'll say right here, and then there it goes. Zeroes it out and starts correcting. Now I know better than to just do it. So this galaxy only needs about 25 seconds. But I am going to increase the gain 300.
You keep it up, and your telescope's going to become self-aware.
It is already.
It's going to pass the Turing test.
It has already.
It's like, I'm sorry,
Okay.
Mark. I cannot do that.
That's right. Open the pod bay doors, please, Hal. I'm
Mark,
sorry,
please
Dave.
shut the roof. It's about to rain. Do it now.
I'm sorry, Dave. You'll have to deposit 25 cents. What?
Sorry, Dave. I love bubble gum. Well, yeah, we should do a cloud check real quick, too. Just in case.
No. All right, now we're doing this here. We're doing this 25 seconds at the lower half of the Andromeda Galaxy.
Andromeda Galaxy.
And let's go here. And it looks like we are still okay.
Oh, no, that was 27 minutes ago.
Yeah. Wow,
Okay.
look at that. All right, we're still okay. Thank
Wow.
you very much.
Sausage.
All right. Yeah, okay. And now let's do this. Look at that. You see? It even
Hey,
goes
look.
beyond.
Proficient came over from P&K over to you. Proficient, meet Alice Pooper. Love it. My kind of humor.
Hey, thanks, Proficient. Glad you joined us. I don't think you'll be sorry unless you are already sorry
Yeah.
because of Keith.
I mean, he
but
did
it's
come from
okay.
P&K, but
No, you know what?
he did come from the Slacker channel.
These people are good people.
We try.
Yeah.
I mean, don't get me
Okay,
wrong. I'd probably
so-
jump ship too if Alice Pooper was over in my stream.
Nah, you know.
You should make Alice Pooper a mod.
You know what? I was actually thinking about that the other night too, because Alice Pooper shows up here and is never abusive and always says nice things, you know, and is quite well behaved like most people.
And look, he put some nice chocolate ice cream emojis in there too.
Oh, that's cool.
Yeah. It's a bit nutty.
Yeah. I did just did add Cosmic Ray as a moderator because he's been doing some nice things for us. All right. There we go. That's pretty good. All right, now. Okay. Let's knock down the red just a bit.
Ray White wants to know, or Wright wants to know, what's the name of the brightest star? Of that brightest star that's in that cluster, because that's how far back they are.
Okay. This is a galaxy. This is the elliptical galaxy. And this is the Andromeda Galaxy.
This is still back on where we were before you got to Andromeda. Yeah.
Is he over in your side?
Hold on, let me just make sure. Yeah, he's in P&K's chat.
So, what were we looking at just before this?
Well, I don't know.
Was
I was
the,
behind because of stupid YouTube. Anyway, yeah.
Okay.
No, he's caught up. He just joined. So yeah, it was the Andromeda.
Or
So
was it
it's
the
actually
Iris?
two galaxies, Ray.
Well, yeah, we don't see the other one. It's out of the shot right now because we're doing this as a mosaic. Okay, we got 8 here. We're gonna do 10 of these, and then go north and do the other half of the galaxy. All right.
12:56.
the Andromeda Galaxy is one of the largest. It's our largest neighbor that we see. It's really something.
It's big.
Yes, and it's actually heading straight for us.
Mm-hmm.
And we are going to collide with it.
Won't even notice.
Yeah. No, we won't. We'll just pass through each other. We'll pass through each other like chips in the night.
Yep. Like water under the fridge.
Yeah. which I have at some points. I've had, which is no fun. Especially when mice are swimming in it. No, I'm just kidding. Wow. Okay, so when you look here, you can see out in the fringes here, you see these right here? These are the Orion nebulas of the Andromeda Galaxy. These are areas where stellar nurseries are. Right? Like that. See that? Stellar nurseries. And then up here, this area is an area where there's hot blue stars that have just formed. These are the spiral arms you can see here. And they go on quite a ways. Something else.
I'm going to tell you what I'm going to do right now is I'm actually going to end the P&K one since it's right at 1 o'clock. That's perfect timing. That's 4 hours exactly on there. But we will continue. Anybody wants to jump over to the SkyTour live stream page where we're still going, feel free to do so. But I'm just going to end the P&K stream right here.
Alrighty.
Jump on over for the last couple minutes if you want.
Okay, we're going to save 15 frames here and then save it exactly as seen. Alright, and then get rid of the stack. Go back to our 1 second and go back to our night vision mode. Okay, and now in this mode we're going to now move northward.
Northward, Squidward.
Oh no, SpongeBob. Yeah.
Thothy.
Right.
Salsy.
And now we'll move this down to here.
So, okay, now you know what? I'm gonna move this over to here because it just looks better.
And then move this over there.
Just like
moving
that.
all these things over here and over there, and it's like
Right.
over here and over everywhere.
Oh, hi, Mark.
There we go. Just like that. There we go.
Okay, we'll come back one level.
I think there's a. Oh yeah, that's still the chat for that. Okay.
Okay, so we're good here. All right. Okay. All right, so now we're gonna do this over here too. So it'll be a 25-second shot here as well. And a live stack here. So that's the lower portion of the galaxy that we imaged. And now we're gonna clear this and see the upper half of the galaxy that we've imaged. And here it is. Boom. And that's gonna be up here. Yeah. There's still more. Okay.
because he's making a mosaic.
That's correct. We didn't move up high enough, apparently.
Still looks fabulous, darling.
Yes, it does. But you know what I'm going to do? I'm going to clear this. I'm going to stop it. And I'm going to move us higher still.
You rebel.
And we'll go. I know, I'm a rebel with a cause. The worst kind. Okay. And now let's do this. And move it further up.
That was pooper.
Still on that.
That's great.
You're gonna dream of Alice Pooper tonight.
Hey, that can't go unrecognized.
It didn't.
Nope. Jesus Christ, how far up are you going?
Well, I'm getting us to the... Remember, the lower half was done. So now I'm doing the upper half. Okay, there we go. Hey, what are you doing?
Ladies and gentlemen, we're taking pictures of Andromeda.
Okay. Alright, so... Move up just to get the core visible. And... move a little bit to east. Alright. Okay, one more and we'll be set.
We will be set.
So now we gotta wait the 12 seconds or so to get our... And we're only doing a 25-second exposure. We could do a minute or so, but we're just gonna do a 25-second.
Mm-hmm.
Okay, so I can get rid of this. And now I go into the live stack. And it's been cleared, and now we'll see the result. We'll pull Andromeda Galaxy out of there. We don't need that.
Hungry fella? There you go. Stack, 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 says Scump 8 Farm Off Grid.
And he is right. He is right. It is important to stack, stack, stack.
Yes. Now we put them together like a puzzle.
Yes.
Oh my. Hmm?
It's like it's got an angry face.
Right? It's coming in like Batman.
I'm talking about this guy's. Here's our angry face. Eyes and mouth. I'm coming for you, Skytor.
You will pay.
It's like, I'm coming for you.
Yeah, it's like the Flash.
How dare you? How dare you stream?
Wow, so that that telescope is pretty far away from Marianne.
It is.
What is it, like an hour?
Couple hours.
Is it? Okay.
Oh yeah.
Gotcha.
Yeah. So this is the upper reaches of the Andromeda Galaxy. You can see another, what we call OB association, very, very hot young stars forming in the spiral arms of the galaxy. That's right, Cindy Murphy. We are looking back in time live. Yep. And you're right. It's about 2.3 million years old that this light is that we're seeing now. It comes into our sensor, it hits the sensor, and we've captured it. And we, interestingly enough, we lose so much light that we don't see. And some of that light might contain interesting information that we don't get to see ever, and never will. It's kind of lonely, huh? The photon travels for such a long distance. But to the photon, you have to understand something. And this is Einstein's relativity that you may or may not be aware of. When the photon leaves the galaxy and comes here, do you think it's on a lonely 2.5 million year or 2.3 million year trip?
You would think, anyway.
Yeah. Well, remember, there's time dilation at the speed of light, right? Time stops effectively. So does that mean that the photon sees an instantaneous trip from the photon's point of view?
No, because it had to get up to the speed of light, doesn't it?
Doesn't have to get up. It's emitted at the speed of light.
See? There you go. Just answered your own question.
No.
I'm sick and tired of figuring this out for you, Mark.
Okay.
Every time I got to give you the answers. It's like a human cheat sheet over here.
Okay. Boy, what would I do without you?
I tell you what.
What would I do without you?
Succeed.
Oh my.
Oh my.
So this galaxy, being about 2.3, 2.4 million light years away, is also big. Our galaxy has about 100 billion stars in it. This galaxy has about 1 trillion stars in it.
It's not the size
So
that
when
matters.
in this particular case, in galaxy world, it's all that matters.
No.
Because that galaxy may retain its integrity by passing through the Milky Way. But the Milky Way is going to be ripped to pieces and absorbed into the Andromeda Galaxy in about 3 billion years. Don't
Sweet.
pack your bags.
Darn. We could all be lonely photons.
That's true.
Yeah.
Yep.
With instantaneous transfer.
Mm-hmm. Well, I mean, let's go back to the 4 fundamental forces. We have the weak force, the strong force, electromagnetic force, and gravity, gravitational force. The electromagnetic and the weak forces and the strong force can all be described with wave equations. Okay? And gravity can now be described as a wave as well. And the strong force, weak force, and electromagnetic force can be described as operating as particles, right? Atoms, muons, gluons, and so ons. Okay? And of course, the photon, right, is a particle of light effectively. What we don't see, what we don't see is gravitational particles, which are what we might call gravitons. But it's not that they don't exist. It's not that they don't exist. Okay, because they certainly may. In fact, I think gravitons do exist.
They're like quarks and stuff.
Whoa! Did you say quarks?
Yeah. Quark.
Shut up, Beavis.
Sorry, I'm getting tired. I'm like, no, I'm losing it.
I know you are.
Yeah.
Okay,
Parks and
well,
stuff.
we that sounds like an entry. That sounds like an entry thing to like a kids show on atomic particles.
It was. Did you ever see that video, The History of Everything?
Yeah,
The animation?
years ago. Yeah.
Yeah. That's what it is. He's like, quirks and stuff.
Okay, and this is our file there. And then we'll save this exactly as seen. Wowee, folks. Well, you've done it again. You've wasted another perfectly good night with us on SkyTour Livestream. I want to thank you guys for coming out. We'll have plenty more to see. All these images are... Everything before the Andromeda Galaxy is probably already up on the server. And all these Andromeda Galaxy images will be up there within a few seconds to a minute or two. Alright? And then you can download them and have fun at your leisure.
Yeah, they can be yours.
Right.
For free.
All for the low price of no 99.
Yep. Come get your stuff for no 99.
Right, that's it. Okay, well, we'll get rid of this. And we'll go back down to 1 second here. All right.
Back down.
Go into
Let's make sure we can get the thing closed.
Yeah, well, that's very important, yeah. It certainly can.
Dude, would you like totally panic if your like roof went to close and it didn't?
That happened.
I know, but like with especially knowing that cloud's coming across. They'd be like, oh no.
I would wake up Marianne and she would head out there.
Yeah.
Which I don't want to do.
Yeah, but sometimes you gotta do stuff what you gotta do, you know.
Yeah.
Like, hey, there's a big rainstorm coming in and the roof is stuck open. Oh,
that's
that would be
happened.
horrible.
Yeah.
I know.
It's been terrible.
Well, it's horrible.
Okay, so what we're going to do now is we're going to park the telescope. And the telescope will move into its park position, which is a good...
Would you say it's a parallel parking?
Oh, well, you see it moving, right?
I mean, does it park parallel?
I won't know.
Is it a parallelogram?
Are we tired, Keith?
Yeah, we're getting there. Yeah, we definitely are. It's 5 hours.
So see, it says parking scope slewing, and it'll tell you to turn the scope off.
How dare it.
And then I run my little program here and turn the scope off. Scope is now off.
Mm-hmm.
And now, oh, look, a cloud.
Just
look
like
at that.
Yeah, see?
Hey,
told you.
No, it's actually in the
Look
south.
like the stars are in like a perfect octagon.
Yeah, I know, huh? And you see them moving across the screen. Telescope's not moving, so you're actually watching the Earth rotating out from under the stars right here. You're actually seeing the rotation of the Earth visually. The universe is dynamic. It's always changing. Okay, and now we're going to close the roof. So here we go. And there goes the roof right there.
There goes the roof.
Yeah, there goes the roof.
For us layman people.
Yep. Well, there you go, folks. Thank you for coming on out to SkyTour Livestream tonight. I'll finish the closing procedure. But great to see you guys. Thank you very much. And I'm hoping, I'm hoping that you guys will come back for the next one. I don't see why not, right? I mean, if people feel like it, yeah.
Yeah. By the way,
They
P&K
will.
tomorrow.
They will.
There's a good possibility, as well as the launch of Artemis, if it happens on Monday.
Yeah, I think Artemis is going to scrub again.
It probably
But
is.
that music tells us that it's time for us to go, and we will be back the next clear night, and that'll be kind of fun. So Keith, thank you so much.
Yes, sir.
You can hang out a
Thank
second
you.
more, because I will have to knock out your volume and mine, and then we'll be able to take care of this.
Yeah.
So you guys have a good night, and we'll see you later. All right?
Take care now. Bye-bye then.
Bye-bye. Bye-bye then.